Okay, this is lesson 55, solving systems by graphing. So this is a bit of a blast from the past type of lesson from Algebra 1, but we're going to be doing harder problems where you have to manipulate numbers. So we use systems of equations in math to find the answer of, it could be two lines crossing together, that's where the answer is, or it could be a quadratic equation, a line. It could be all sorts of things, and it depends what the model is. And in real life, we use this all the time. So raise your hand if you take an econ, or you're going to, or yeah, you take an econ here, or you're taking econ right now. Okay. So do you remember this concept where we had a demand and supply curve? Here's your demand curve and your supply curve. Raise your hand if you remember this. Okay. So with your demand curve, let's say we just focus on the demand curve. If this is your price, let's say you sold, let's think of a product. Make something up. What's something that people sell? iPhones. Okay, good. All right. So let's say it's iPhones, okay? So the Apple could sell iPhones for really cheap. Let's just say they sell them for $50, okay, down here. If the people who would buy it, if iPhones were $50 each, do you think more people would buy iPhones? I think right now 2 billion people on the earth have iPhones, or like 1 billion people have iPhones, okay? So do you think everyone would get an iPhone if they were only $50, right? So let's say it's $50 times, let's say 5 billion people. It's a lot of money, but it's not all the money that they can make. Or they could have chosen to sell the iPhones for, let's say, $1,500, okay? Who would buy iPhones for $1,500? Would you buy them for $1,500? Would someone buy them at least, though? Yeah, there might be a couple of rich people, right? There might be like 100 million rich people that still buy them, right? But not everyone. So the way that you find profit is you multiply the price times however many people buy it, right? Or how many people, buy the product. So they could sell them for $50 and they could sell them to a lot of people. Or they could sell them for $1,500 and sell them for less people. But it's not the maximum profit. They have a supply curve that looks like, let's just pretend to look like this, right? These are two lines mathematically. The answer to how much they should charge is right here at this point here. Because if they're selling it at this price point, let's say it is like $700, and they sell it to this many people, well, their profit now is this length times this width. Does that make sense? Which is a lot more area. So this is how they figure out how much money to sell products for. Does that make sense? Okay. Raise your hand if you remember this from econ. Okay. So we're trying to find the point of where the lines cross. The answer is where they cross. And if you're going to be a business major or econ major in college, then you're going to deal with this stuff. Okay? Here we go. So here are the steps. If you're on the video, you should stop or pause the video right now and write them down. But the big concept here is, where do the lines cross, okay? Where the lines cross. So we're figuring that out. And if they don't cross, it is no solution, okay? No solution. Here we go. Number one, we have two lines that are already solved as slope-intercept form. So the way we solve it now is we find the y-intercept of each. The first one, the y-intercept is -3. Slope is 1, right? 1 over 1. So we go up 1 over 1. We already know how to graph, right? So graph each of the lines. And you take your straight edge. This is the important part, is taking a straight edge and being precise. Putting arrows at the end. Next line, the y-intercept is at +4. Slope is -3/4, so we go down 1, 2, 3 over 1, 2, 3, 4. Put a point here, and it looks like this is a shared point. I can't really put any more points on this particular graph because there's not enough space. But we know that these lines go on forever. Okay, graph a couple arrows at the end, and we notice that there's a shared point here. Okay, so what's the name of the shared point? It is, the coordinate is 4, 1. Okay, So that would be the answer here, is where the lines cross form 1. So what did I do? First thing I checked it was in slope-intercept form, it was already. Then I graphed each line, found where they intersect. That's where your solution is, okay? 4, 1. Okay, number 2 is a lot harder. Is it in slope-intercept form already? No, it's not. So since it's not, we have to manipulate the numbers. So this is the other concept we were working on. Is sometimes in math you have to manipulate the numbers so that they work for you, okay? So I need to, first equation, I need to isolate the y, so I'm going to subtract x on both sides. So it's going to be 3y is equal to negative x minus 18. Divide both sides by 3, so y is equal to negative 1/3 x minus 6. So on this particular equation now, it's in slope-intercept form. I'm plotting my y-intercept. Slope is negative 1/3, down 1 over 1, 2, 3. Again, down 1 over 3, down 1 over 3. We could go the opposite way as well. Plot my points and draw my line. Okay, next equation. Also not in slope-intercept form, so I'm going to subtract 2x on both sides, so it's going to be negative 3y is equal to negative 2x plus 9. Okay, dividing both sides by negative 3. So we're going to have y is equal to positive 2/3 x minus 3. Yep. So you go to negative 3, plot your point, and then we're saying that the slope is negative 2/3, so we're going to go up 2 over 1, 2, 3, plot a point, up 2 over 3, up 2 over 3, and then the opposite direction we go down 2 over 3, down 2 over 3, and notice that there's already a common point here, so that's going to be your hint that you're doing it correctly. And we plot your points like so, and arrows at the end. Step 3, where do the lines cross? They cross here. This point, what's the name of this point specifically? Well, it is at negative 1, 2, 3, down 1, 2, 3, 4, 5. Negative 4, 5. So negative 4, negative 5 is your answer. Okay? Any questions on 1 or 2? Okay, so again, the emphasis is where do the lines cross? Sometimes it's not a perfect problem, so you have to manipulate the numbers. You have to own the problem. So moving things around so that they're equal to y. Okay, and that's it. Raise your hand if you remember this from Algebra 1. Vaguely, at least. Okay, good. Raise your hand if this is new to you. Okay, looks like it's not. So, all right, it's Monday. Let's have 1 solid 2 is about number 1, 2 solid is about number 2. Let's talk about it, and then you can write about it. Ready, set, go. All right, continuing here, number 3. Oh, sorry about that. Number 3, here we go. Y is equal to negative 1/4 x minus 2, and y is equal to negative x plus 1. Turn to your neighbor, tell them, is step 1 done, or do we need to do step 1? Do we need to put it in a slope-intercept form, yes or no? No, it's already done for us, okay? So let's do this one together. The first one, slope, is negative 1/4, y-intercept negative 2. So write the y-intercept first. Slope is negative 1/4, so you're going to go down 1 over 1, 2, 3, 4. Okay. Again, we're going to go the opposite way. We don't have enough space. We're going to put a point the opposite way. By the way, the denominator of the slope is always positive, right? Remember that? It's always positive. Okay, next is the other equation. What's the slope of the other equation? Second equation? Negative 1 over 1. Y-intercept? Y-intercept? 1. Okay, so we're going to go down 1 over 1. Plot a point. Down 1 over 1. And then looks like we're in the right direction because we have an intersecting point or a common point. Draw my lines, okay? Now tell me what the, finish up and tell me what the solution is. I'll come around and check your work right now. So this one is, looking here, it's 4, -3. That's your solution. And on this 4, -3, what does this mean? It means this is the one point that if you were to plug it into both equations, you'd get the same answer, or same value for y. Okay? So you get two balanced equations. Number 4. Okay, number 4, turn to your neighbor, tell them what's one similarity and one difference that you're noticing on number 4. Before we even start, what's one similarity and one difference? And tell your neighbor first. I'll ask for your answer in a moment. Okay, what's the difference on this one? What's the difference? How are the two equations different on number 4? Raise your hand when you have an answer. Yeah. The y-intercepts are different, right? If you look at number 4, we know this one has two different y-intercepts of 3 and 1. What about the slopes? Are they what do you notice that's the same? They're both equal, right? Think back to geometry. When you have two lines that have the same slope, what do we know about the lines? They're parallel, right? Remember that? Lines with the same slope are parallel geometry, right? So if they're parallel, what do we know about the answer here? No solution, because the lines will never cross. So we would just write no solution on this one. Okay? So this is a fun one, right? It's like, yes, I'm done with this problem. If you didn't know how to do it, you just, this is what the lines would look like. And they would be parallel. Okay, so keep that in mind as you are looking for shortcuts, right? You want to save time when you do homework. Next one, number 3. Okay. This one I'll start you off and then you'll finish the rest. Are they in slope-intercept form? No, so you take your first equation and you're going to subtract 3x. So you got y is equal to negative 3x minus 3. And it's already in slope-intercept form, so now we just have to plot this one. So I'll plot this and then you're going to finish the rest of the problem, okay? You'll have to manipulate the second equation. Most of you got it, but there's a few variations and answers, so I want to make sure you get it. So on this particular problem, or on this particular equation, I'm noticing that it's not in standard form. So I'm going to add y and subtract 7 on both sides. This would be y is equal to x minus 7. Alright. So you go to negative 7, plot your point. And then the slope is 1. So you go up 1 over 1, up 1 over 1, up 1 over 1, and so forth.
Isn't the y negative, so you have to...
It is. So this would be the, you'd have to add y and subtract 7. Do you want me to show you a different way to do it? I skipped a couple steps. So do you want me to show you how I got to that answer? Raise your hand if you want me to show you how I got that. Okay. Just want to make sure you guys got that. Okay, plot your point. So your line should look like this, right? So your answer is going to be over here. What is this point? It's 1, negative 6. Okay. That's your answer. That's the solution of this system. All right. Last one, number 6. Okay, number 6. This one's by yourself. Apply anything you learned up until now. Patterns, shortcuts. So last one's no solution. I'm not going to show the work on this one because you just put it into proper order. But you notice that on each of these the slopes will be the same, which will be 3x. Each of these slopes is 3 over 1. So you know it's no solution because lines that are the same at the same slope are parallel. Now what if you had two lines that looked exactly the same, like the same y-intercept and the same slope? What does that really look like? One line, right? It would be one line, you draw one line, and then you take the other line and draw the second line over it. So what does that mean when they're all on the same line? How many times are both lines touching all real numbers, right? They're touching infinitely on both lines. Does that make sense? So we'd say all real numbers. But if they're not touching, it's no solution. All right? And that concludes this lesson. So you could turn off your iPads, clean up your work a little bit on there, and discuss these questions with your neighbor.